Today we'll start with the topic spherical flame. NASA of United States of America has recently discovered that gravity plays an important role in flame formation. In zero gravity, the efficiency of flame goes to maximum. In zero gravity, spherical flame front is formed. The flame is more bluish and efficient in such conditions. The flame looks like this. Because of complete combustion of products and products moving away from the source of flame, it is more bluish and burning with more efficiency. Next topic is fuels. Fuels are substances that produce heat and light energy on burning. Some examples are wood, coal, kerosene, LPG, etc. Now we'll discuss about types of fuels. Fuels can be classified as first is solid fuels. Fuels that exist in solid state at room temperature. The examples are firewood, that is burnt and produces energy, charcoal, agricultural waste, and coal. All these exist in solid state at room temperature, hence these are solid fuels. Second type is liquid fuels. Fuels that exist in liquid state at room temperature. As they are existing in liquid state at room temperature, hence called liquid fuels. Some common examples are kerosene, petrol, diesel, etc. Third type of fuels are gaseous fuels. Fuels that exist in gaseous state at room temperature are known as gaseous fuels. The examples are petroleum gas, natural gas, this was a classification on the basis of physical state of fuel at room temperature. If physical state was solid, those were called solid fuels. When physical state was liquid, the fuels were called liquid fuels, and when physical state is gaseous, the fuels are called gaseous fuels. Now characteristics of fuels. Characteristics of fuels. Some important characteristics of fuels are as follows. The first is calorific value. Now calorific value can be understood as it is the amount of heat produced by complete combustion of per unit mass of fuel. That is known as calorific value. Okay, that is, if we take unit mass of fuel on burning, the amount of energy produced is calorific value of that fuel. If a fuel has higher calorific value, it will produce more amount of heat when it is burned. If a fuel has lower calorific value, it will produce less amount of heat when it is burned. So higher the calorific value, better will be the fuel. Now calorific value of some fuels are as follows. Unit of calorific value is kilojoules per gram. The solid fuel cow dung cake, it has calorific value 7. The solid fuel wood, it has calorific value 17. The solid fuel coal, it has calorific value between 25 to 33. The solid fuel coke, it has calorific value 33. The solid fuel charcoal, it has calorific value 35. The gaseous fuel biogas, it has calorific value between 35 to 40. The liquid fuel petrol, it has calorific value 47. The liquid fuel kerosene, it has calorific value 48. The gaseous fuel LPG, that is liquefied petroleum gas, it has calorific value 50. Another gaseous fuel methane, that is present in CNG, compressed natural gas, it has calorific value 55. And hydrogen, it has calorific value 150. All the calorific values are in kilojoules per gram. Here we can see the solid fuels have low calorific value and the gaseous fuels, they have quite high calorific value. The reason is solid fuels, they undergo incomplete combustion, so less amount of energy is produced, and gaseous fuel, they undergo complete combustion, so large amount of energy is produced. The next property is efficiency. When fuel is burned, some of the energy produced is given off as waste heat. It cannot be used for cooking or other purpose. So the efficiency of fuel is decreased. The energy of fuels can be converted into usable forms of energy such as heat and mechanical energy. Here we can understand efficiency as the energy which is used out of the total energy produced. So it usable energy out of total energy produced. One form of energy is converted to another form of energy with the help of some energy conversion devices. Energy conversion devices convert one form of energy to another form. Efficiencies of some energy conversion devices are given as follows: energy efficiency and efficiency of that device. Solar cells, they have 10% efficiency, that is, out of total energy produced they can utilize only 10% of energy. The rest of energy is wasted. Petrol engine, they have 25% efficiency. Diesel engine, they have 38% efficiency. Fossil fuel powered electricity generating plant, it has efficiency of 40%. And wood stove, it has maximum efficiency, that is 66%. So quicker is the burning process, the amount of energy would be released quite large and less amount of energy would be utilized. So efficiency of these energy conversion devices are less, like petrol engine, diesel engine. And in case of wood stove, as there is a slow combustion process, so amount of energy released is slow. It is released slowly, so maximum amount of energy is utilized, so its efficiency is 66%. Now we'll talk about characteristics of an ideal fuel. Means what characteristics should be there in ideal fuel that can be utilized. The first characteristic, ideal fuel should have high calorific value, that is, its unit mass on burning should produce maximum amount of heat. The second characteristic, ideal fuel should not produce any harmful gas, that is, it should burn without giving any harmful gas. In their combustion, no poisonous gases should be produced. The third characteristic, ideal fuel should have proper ignition temperature. We have already discussed about ignition temperature, that is the minimum temperature at which any substance starts burning. Fuel should not have any other more valuable use than the burning. Next important characteristic, fuel should not have valuable use other than the fuel. Just for example, coke is good fuel, but it is more valuable as a reducing agent in the extraction of metals. So coke should not be used as a fuel. It should be better used as reducing agent in metallurgy. The next one is fuel should be cheap and easily available. An ideal fuel is that which is not too expensive and is available easily in plenty everywhere. Ideal fuel should be easy to handle, safe to transport, and convenient to store. It should not create any safety risks during handling, during its transportation from one place to another, or during its storage. On burning, it should not leave much residue behind. An ideal fuel should burn completely without leaving much ash behind, so it would create less pollution. The next property is it should burn smoothly. That is, ideal fuel should burn at moderate rate. That is, neither too fast nor too slow. If fuel would burn too fast, then large amount of energy would be produced, and all energy won't be utilized. Large part of energy would be wasted. If fuel is burning too slow, it will take too much time to produce the required amount of energy. Now, next heading is burning of fuels lead to harmful products. On burning fuel, many products are formed. Some of them are harmful for the environment. Some examples are as follows. On burning carbon fuels like wood, coal, petroleum, they produce unburned carbon particles. These unburned carbon particles causes respiratory disease such as asthma. Now, if fuel is undergoing incomplete combustion, it will produce harmful gas carbon monoxide. It is a very poisonous gas. Carbon monoxide gas produced can kill persons sleeping in closed room. Combustion of most fuels produces carbon dioxide that increases the concentration of carbon dioxide in air and causes global warming. Burning of coal and diesel produces sulfur dioxide gas. It is very suffocating. Petrol engine gives off gaseous oxides of carbon. Petrol engine gives off gaseous oxides of nitrogen. Oxides of sulfur and nitrogen dissolve in rainwater and form acids. That is called acid rain. Acid rain is very harmful for crops, buildings and soil, as these changes the nature of these substances and corrode them. Nowadays use of diesel and petrol fuel is replaced by CNG in automobiles. CNG is a cleaner fuel.